different forms. We said you could graph when you were in slope-intercept, so I'm going to give you something like negative 2/5 x plus 6. Or we can graph from standard form. Okay. Why is it super-duper easy to graph when you're in slope-intercept form like the first one?
All you gotta do go is down 2/5.
Okay. So Andrew said yes, we would go down 2/5 for our slope. I'll buy that. But how do you know where to start counting from? Yes. Yes, we know 6 is the y-intercept. Negative 2/5 is the slope. So you start. Do I count over 6 or up 6? It's a y-intercept. So you got to be on the y-axis. I start up 6, and then I start counting. How do you know whether the negative goes with the 2 or the 5?
It don't matter.
It doesn't matter. It only goes with one of them. So we can do it like it's negative 2/5. So we can do rise is down 2.
Down 2 and right 2.
And right 5.
Yeah.
Okay, and I would recommend you do at least 3 points. Okay. But if you did it the other way, if you had treated it as positive 2 over negative 5, you'll still get the same line, because that would say go up 2 and left 5. And I would end up over here, and I'm still going to be on the same line. So just put the negative on one of them. Put the negative with the top number or the bottom. Yeah. You can, yes, do it on the, you use the lid of your calculator will help you draw a line.
Yeah, well, Curtis, guess what? You got it.
Okay, because I am going to, I don't have solid lines on. Solid lines. Alright, I'm going to cheat and use my straight line tool. Uh-oh, and I didn't count right either. Y'all supposed to tell me I didn't count right.
Well, you didn't count right. I knew it. I was like, what is she doing?
That wasn't 5 over, that was only 4 over.
Don't forget your arrows. Yeah.
Okay, at this level of math, we don't bother to write arrows anymore.
What? Mr. Thomas yelled at us every time. Yeah.
We just extend them off the edges, and it's understood that there is a steady.
It's because this is a different level, guys.
This is the more smart.
You won't see them put arrows on things.
Well, not even a scientist. You need to go tell Mr. Thomas that.
Well, in Algebra 1 we do. Here we're more sophisticated, a little more advanced.
Geometry.
Okay, so that was easy and normal.
Geometry.
Okay. This, hear me well. Everybody tune in. This is a my way or the highway situation.
Highways. They go
You
fast.
will do this my way.
Highways are fast.
I'm running out of time. Okay. Yes, you could rearrange this. Move the x over. You could move it into slope-intercept form so it's y equals. But what happens when we start rearranging equations?
You missign it.
We make mistakes and we mess stuff up and we get errors in it. You can graph from this form right here, and the cool part, at the same time as you're graphing it, you're getting yourself the x and y intercepts immediately. Okay. Would you all agree that when we cross the y-axis, like on this point, we're at the point 0 over and 6 up?
Yeah.
And when I cross this one, I'm at, yikes, 2, 4, 6, 8, 10, 12. I'm at 14, 0. Okay, notice when you're on the x-intercept has a y-coordinate of 0. The y-intercept, x is 0. Okay, so if you're in standard form, the easiest way to graph it is to substitute a 0 in for each variable. So I'm going to put 0 in for y. If I put 0 in for y, isn't that whole term gone? And I'm left with 2x equals 18. Can you solve that? 9. So therefore I have the point 90.
Okay, can you go over that again?
You sub 0 in for y, you put 0 in for y, that's gone.
Yep. I just erased it right now.
And so I have 2x equals 18. Now do the reverse. Put 0 in for x. That term's gone. And divide by -6, which would make you have -3. That's the actual x and y intercepts. You're at 9, 0, and 0, -3, you can draw a line there and you got it. All you have to-
0 and 6 -3.
Yes.
Or 0 negative.
So that literally is, you just got, right there, you just found that's the x-intercept and the y-intercept. And the beauty of this is, for every other graph we do this year, if you need this, if any graph ever, if you need the x and y intercepts, all you have to do is sub-zero in whatever equation you're working with. Sub-zero into y and you'll get an x-intercept, and if you sub-zero in for x, you'll get a y-intercept. That's how you find x and y-intercepts, always, on any graph, ever, not just line.
Oh my gosh, I feel like I learned.
Well, I hope so. That's kind of the goal. Now, I didn't get my line too out, so I'm kind of crooked there, but that's all it takes. Sub, if you're in standard form, just sub the zero in. It's so easy. Okay, you all are supposed to graph two lines on your calculators, which is super simple. I just need to show you where to go.
Alright, tell me where to go.
We got 3 minutes.
Yeah, well, I think I can do this in about one, once I get it to load. It's late seminar today, yes.
It is recording.
Goodness, this is taking a long time. Let's go. No, I'm still recording, yes. I could have been. Oh, dude. Why didn't it go? It's simple though. There it goes. Okay. You will need to go to imagine this, a graph page.
Oh, you forgot to add the graph page.
Sorry. Fine. Okay. When you get on a graph page, you need to type in the equation you want to graph down here on this F1. Now, half the time you won't be able to see it. If you ever can't get down there to that, press tab. Tab will always take you to that line. Okay, and then all you do is you type in the equation, 3x minus 4. X is down here on your keyboard. It's just an X. Press enter. Now, to type it in though, your equation has to be y equals. What if they give you an equation that's not written as y equals? You have to solve it into y equals form and then type it in your calculator. It has to be y equals. That's simple.
So wait, we can check our answer?
Yeah, you could. Yeah, you can check your answer on there. That's all you have to do.